Hello and welcome back to part 2 of section 2.2 of geometry. Let's now complete the example problems together. In example 1, we are finding the truth values of conjunctions. Use the following statements to write a compound statement for each conjunction. Then find its truth value. Explain your reasoning. So statement P is the figure is a triangle. Statement Q, the figure has two congruent sides. Statement R, the figure has three acute angles. Since we're finding the truth value of the conjunction, I think we should start with finding the truth value of each individual statement. The figure is a triangle. That's true. Figure has two congruent sides. They are marked here and here, so that is true. Figure has three acute angles. I see one, I see two, but this is a right angle. That's not acute. Therefore, this statement is false. So, P and R say the figure is a triangle. That's part P. And R, the figure, has three acute angles. And it has three acute angles. In order for the conjunction and to be true, both of them must be true. It is a triangle, but it doesn't have three acute angles. So this statement is false. Because part R is false. How about this one? That looks like an N, so this is an and, Q, and not R. So Q says the figure has two congruent sides and it has three acute angles. Oh, but we are negating R, not R. And it does not have three acute angles, which is true. It has two acute angles. It doesn't have three acute angles. So that portion is now true. So the figure has two congruent sides, true, and it doesn't have three acute angles, also true. True and true makes more truth. This is true. How about example 2? Truth value of disjunctions. Same thing, write the compound statement, find its truth value, explain your reasoning. Statement B says January is a fall month. I believe that would be false. Statement Q, January has only 30 days. I believe that one's also false. January has 31. Statement R, January 1 is the first day of a new year. In Western civilizations, yes. So, to write P or R, we would write January is a fall month, or January 1st is the first day of a new year. So one of those is true, so that means the statement as a whole is true. At least one side, one part is true. How about B? This is P, that's not an N, that's upside down, so it's an or, P or Q. So now January is a fall month, or it has 30 days. January is a fall month, or it has 30 days. Those are your options. You have to choose one. Choose wisely. I can't choose either of those. Those are both false. This whole thing is always going to be false. Neither option is true. And then we have not P or R. Not P, January is not a fall month. Not a fall month. Or R, January 1 is the first day of the new year. Or Jan 1 is first day of new year. Well, now both of them are true. January 1 is the first day. Yes, true. January is not a fall month. Also true. So the whole statement is true. For the same reason as we have up here. At least one of them is true. It happens to be both of them, but 2 parts is at least 1 part. Okay, example 3, constructing truth tables. Let's try to visualize and sort out this combination here, not P or Q. I think that was, it's kind of like what we did up here with statement C. So if you weren't sure how that works out, why is that always true? We have always start with statements P and Q, and statement P and Q can be true or false themselves. And I always make the 4 set here to get every combination. You've got 2 different statements, each of which has 2 truth values, so there's 4 total combinations. True, 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 false, false, true, false, false. And then we need not P. Notice this negation is only on the not P. This is not equal to the negation of the whole thing, P or Q. I'm not trying to confuse you. I'm trying to point out something else that might show up that you don't want to mix this up with. But this does determine sort of our order of operations, exactly like a negative number and multiplying here. We've negated P. We haven't negated the combination of P times Q, if that makes sense. Or P plus Q, or P minus, whatever operation is there. So I need to figure out not P first. So we're just going to copy the column P and reverse all of them. If P was true, well, now it's false. And if it was false, then now it is true. So now when we look at not P or Q, what we're going to do is check, do I have at least one T among these 2 columns. So let's look here. In the first row, I have T and F. So not P or Q, could be F or T, could be false or true. So the not P is false, Q is true. I have at least one of them. So if I get to freely choose, you must select not P or Q. Well, I could choose Q, so I can get truth out of that. Then next row, both false. So I have to choose a truth out of that. I can't. Okay. Next row, T or T. Oh, that's easy. I can definitely get truth out of that. And then last row, false or true. I can get truth out of that. So is this always true? No. Is it always false? No. This is, so we can say that not P or Q is only false when, let's look back at the original statement. So it was false when I had both of these were false, but what does that say about the original combination? When P was true, but Q is false. When P is true and Q is false. And remember, P and Q stand in for whatever statements we are working with at the time. Okay, example 4, Venn diagrams. This Venn diagram shows the number of people who can or cannot attend the May or the June Spanish club meetings. I'm guessing can is inside, and then notice there's these two guys out here. I guess cannot attend either meeting. So how many can attend the May or June meeting? We have 5 can attend May, 14 can attend June. You get to freely choose May or June. Great. There's 6 that could do both. That includes, they're included in the or. So that's everybody. 5 plus 6 plus 14. 6 plus 14 is 20, plus 5 more is 25. People. How many people can attend both the May and the June meeting? Well, then from the Venn diagram, we're looking only at the intersection. So that would be only the guys in the middle. So that would just be 6 people. Okay. And C, describe the meetings that the 14 people located in the non-intersecting portion of the June region can attend. That would be 14, and they can attend the June meeting, clearly. Those 14 can attend June meeting, but they're not in the intersection, but not the, what was the other one? May, but not the May meeting. Because if they could do May, they would then be inside the intersection in the purple middle there. Okay, that's the final example. So long, farewell. Enjoy the rest of your day.